All right, we're looking at 1.5, day 2, composition of functions. Basically what it means is putting the one function within another. So if I have the first function, f of x, and I have an input, okay? From that input, I then get an output. This output now becomes the input for, let's say, a second function, g of x, and then I would have an additional output at the end. Okay, so it takes one input from f of x, which has then an output. That output becomes the input for g of x, and out it goes. What you've seen is f of g of x, where the g of x is in the f box here. This little open dot means the same thing, f of g of x, where I'd be substituting the function of g, okay, the inputs of g into, or the outputs of g into the function f. So if I'm looking at a basic one, like evaluating a function, first thing I need to do is, what's my input to g? My input of g is g of 2. So I'm going to evaluate g of 2. G of 2 then is 4 times 2 squared plus 1. So that is 4 times 4, 16 plus 1. So g of 2 is equal to 17. This is my output. It now becomes my input for f. So I'm looking at f of 17. So f of 17 is 2 times 17 plus 5. That would be 34 plus 5, 39. So the composition function evaluated at 2, f of g of 2 is equal to 39. Okay. The next slide, notice the input value. There is no value. There is no whole number. There's no value for x. So what it's saying is, let's take this function g and put it into the function of f. So the function of g is 4x squared plus 1. So I'm evaluating the function f at 4x squared plus 1. So this part here now is substituted into the x value there. Okay, so then I have 8x squared plus 2 plus 5. So the composition function f of g of x is equal to 8x squared plus 7. You don't always have to have f of g. You can have g of f. In this case, so what I'm taking is, then I'm substituting the function f into the function g. So I'm looking at g of f, which is 2x plus 5, and I'm substituting it into the function g. Okay. So again, remember, we go over to our thought bubble and we do 2x plus 5 times 2x plus 5, so that we can get 4x squared plus 20x plus 25. Okay, that's 2x squared plus 5. 2x plus 5 squared. Now let's distribute. And add 1. So my function, my composition function of g of f of x is equal to 16x squared plus 80x plus 101. I can also compose a function with itself. So what this is saying is, I'm going to take the function f and put it back into itself. So the function f is 2x plus 5. We're going to substitute it into itself. So here's my function f of x in my function f of x. Now distribute. So that's 4x plus 15. So this is my function f of x. Sometimes looking at the domain of given functions of compositions gets a little confusing. So what you want to do is look at what is the domain of my inputted function. Okay, what is the domain of my function that I'm putting into the other one? So the domain of g of x, so I'm looking at g of x, the domain of g of x is all real numbers. It's a polynomial. So far I can put any number into g of x. So when I compose that, when I do the composition of f of g of x, I'm saying that I'm going to take f of x minus 1, because I'm putting g of x into f of x. So that's a square root of x minus 1. Okay. So now I have to determine the domain. Since my original function was not restricted by any means, I could then substitute it, and then I can look at just the domain of my new function of my composition. So my domain for my composition, I know x minus 1 has to be greater than or equal to 0. So x is greater than or equal to 1. That is the domain of my composition. Okay. It's not too bad when I know that I'm putting all real numbers into my second function, because then I only have to look at the restrictions on the second function. It gets very different and much more complicated when the domain of my original function is restricted. So we're first going to find the domain of this function. We know that that has to be greater than or equal to 0. Okay, so 9 has to be greater than or equal to x squared plus or minus 3, taking the square root. So now I have to look at my values and determine which direction and which inequalities are true. So I'm going to say first is x less than, because the little part's on the x right there, is x less than or equal to 3 true for all numbers. Okay. X less than 3 is true. If x is 3, it's true. If it's 2, it's true, and so on. Okay, so that works. If I say x, so that's true so far. X less than or equal to negative 3, is that true? Negative, let's plug in negative 4. 9 minus negative 4 squared, 9 minus 16. That is not true. So what I'm going to do is I'm going to switch the inequalities, see if that's true. Okay, let's try negative 2. So 9 minus negative 2 squared is 9 minus 4. That's true. Well, if you look at how this is written, okay, I can rewrite my domain. It is now an AND domain restriction. So negative 3, my x's are greater than, that's this one here. X's are greater than negative 3, and then less than 3. So my first original domain is restricted. So when I come down to doing the composition here, if I'm going to put f of x into g of x, I need to, let's do that composition. G of f of x, it's the same thing as saying g of the square root 9 minus x squared. So I'm plugging f of x into here. So square root 9 minus x squared, quantity squared, minus 9. Well, the square and the square root are inverse operations, so they're going to cancel each other out. And I get 9 minus x squared minus 9. 9 minus 9 is 0. So the composition function is 9 minus x squared. So, big note here. This is really, really important. The domain of the composition looks like it should be all real numbers. However, this is the part right here. However, okay. However, there was a restriction on the domain of the inputted function. In other words, there was a restriction on f of x. So the restriction applies to the composition. So the domain of g of f of x is -3 less than or equal to x less than or equal to 3. Okay, so when you have a restriction on the inputted or the first function, then that restriction also applies to the second function.